Hey everybody, this is Larry. This is day 10 of the Leetcode Day Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about this one. I always, man, we're doing a lot of like repeats. I guess 3306 is a recent contest or something. But yeah, I like to always point out. I don't think I realized this the last couple of years, or at least on stream. But today is March 10th, which is Mario Day. Yay! I don't know. That's all I have. That's my fun fact for you, alright? So if you're watching this, happy Super Mario to you. I ran a 10K today, just casual, easy run. Just trying to get my head back in shape. But yeah, I don't know. That's pretty much it, really. You know, some days you just need to do the easy things, you know, so you can both rest and also not rest, right? And just work on different systems. But yeah, okay. Let's take a look at today's problem. We have 3306 count of substrings containing every vowel and k consonants 2. Okay, so you're given a string word and a non-negative integer k. Return the number of substring word that contains every vowel at least once in exactly k consonants. Okay. I mean, this seems pretty straightforward. Sliding window, just tracking stuff, right? When did I last do this? This is like barely half a year, so I imagine my video on that one is decent. If you're watching today's video, well, as you're watching now, this video is today's video, then I'm gonna maybe disappoint because I feel like, you know, we've been on a couple of days of sliding window and I've done these forms before, so I don't know what to say. But basically, there is this idea of, yeah. Actually, But this is a little bit annoying / tricky one, though, right? Because I think I misread this for a second, which is that you want every value at least once and exactly k consonants. So here, so maybe that is the difference is that the sliding window, if you want to call it that, because we'll explore different ways of thinking about it in a sec, is variable length, right? It's not a fixed window where you slide in one character, slide out one character, which honestly is pretty straightforward at this time. But yeah, okay. So the way that I want to think about it then is instead maybe this idea of contribution, right? Meaning that, okay, so you have a word for every character that is the last character, how much contribution does it have to the final answer, right? So yeah, and a lot of this is going to be bookkeeping, right? And it's just thinking about what is the right level of bookkeeping. And honestly, for me, for now, I don't know. Right? But here we want to say for right in range of n, where n is equal to word. I don't know that this is the right thing yet. Honestly, I don't know the answer off my head. Or I mean, I know the ideas, but I don't have the precise answer, right? But okay, so then here, and there are a couple of ideas that you can think of, right? One is the sliding window, which may or may not be the idea. Another may be like binary search, right? So if this character is the last character, how you can try to binary search the smallest instance and then the largest instance. And then if that's the way you want to think about it, then you have to set up infrastructure or data structure to kind of be able to answer that very quickly, right? Otherwise, if it costs you n to binary search and you have to do it for every character, that's already n square log n or something, right? So it definitely could be very sketch. Just want to confirm that I'm not doing crazy things and that n is actually big, right? Excuse me. I think the idea here, though, is that you have to try to figure out what I would call invariance in between iterations of these boundaries, right? If you want to call it a window-ish thing. And the idea that is that it has exactly k consonants. So that is the thing that is invariant. And if that's an invariant, how do you exploit that, right? So how many, if we're talking about count of substrings, well, you have to have at least k consonants, and then it's about going to the left to start with all the number of ways to have all the values at least once, and then all the way to an extra consonant, right? Because when you have an extra consonant, then it goes to k plus 1. So I think one way that I would suggest doing when you're like, I think I got most of it in my head, which is maybe good, maybe not, I don't know, right, in terms of learning. But the way that I would kind of recommend thinking about it is initially write out the n squared solution. I know that n squared is too slow. N is, what is it? 10 to the 5th, 2 times 10 to the 5th, in fact. So it's definitely way too slow. But I want you to kind of think about how that would look, right? So here, maybe I would write something like, okay, for left, or maybe we start left is equal to right, right? So then now we might write something like, I don't know, value is equal to collection.counter, something like that, maybe, right? Or maybe it's not even a counter, it's just, you could use a bit mask, but whatever. Let's just use 4 times 5, right? So it's just basically whether we've seen either one of the values, and then here we can have vs is equal to a-e-i-o-u, right? So that's how I would start thinking about it, and then now we just consume, right? While left is greater than 0, or equal to 0, we go, okay, if, and maybe we have a k count is equal to 0, consonant count, right? And if where is it? Word sub left is equal to, or is in vs, that means that it is a value, and then word sub left, the vx index of this, we want to say v of this is equal to true, right? So we want to set it to true, right? Otherwise, k count increment by 1. And then now we want to check one thing, which is that, yeah. There are a couple of ways you can write this. I'm going to write this dumb for now, but we can, even for this, we can optimize, but I don't want to premature optimize. We have to optimize a lot of things anyway, right? So then if all of v, so that means if all the values are met, and k count is exactly k, then now we can break, right? Because this is the first time this has happened. Otherwise, well, we don't break. And also, it may never break. With, for example, if we don't have enough consonants, or if we just never have enough v, right? So, and then now we can do maybe while or v and k count is equal to k. If, I did forget something, which is we have to subtract 1, right? Obviously. And then now if word, or while this is true, well, all v is always going to be true after that because you can only add more characters. So while k count is equal to k, and left is greater than 0, I suppose. If word left is not in vs, then k count, then it's a constant, and we increment, right? And that will effectively end the loop, right? Yeah. So these are kind of ways, and of course you can add a counter here for the total, because then now this means that if we break, this means that, okay, we found one example, right? So maybe we, yeah, well, this is true now, so this is true now, so then total increment by 1, and then we do this thing, and then, oh, and this is subtract by 1, whoops, right? And then now at the very end we can return total, right? And this should be good. I mean, it's going to time out, I expect, and I don't know, maybe apparently there's something off. Why is this? All right, well, but you know, but I know that I'm writing an n squared solution, but this is kind of just to kind of give us an Why is it? Oh, I have to click on view mode. That's why. But yeah, I just want to see. Well, if the n squared solution doesn't work, you have a lot of things to do, right? So okay, so here I think. Okay, so then 1. So then now we have 1. Oh, which one is 12? I guess we could just print it. Was it word of right? So it's this Q, which already doesn't look right? Q E I O U. So then now, yeah, why does that increment twice? Because it's left is equal to 0. Oh no, this isn't. Oh no! I see. Do I? Yeah. I mean, So this is true. So we increment, but because on this break we don't decrement yet. That's why. So then now the first one is counted again. Well, the first one is counted, but then we decrement. But this is on the character where that is not true, right? So we still have to. I think fix it by doing this. Oops. Yeah. Okay. That makes sense. I just was a little bit sloppy. But yeah, so of course we know that this is gonna be too slow. It is n squared, right? This loop goes all the way from right to 0, and you have n squared. It's a really easy count. And then the idea is, okay, now that we have this, can we optimize it in a way such that we get rid of an n factor, right? Well, with sliding window, you kind of can, right? The idea here is that if you have a window, what would that look like? When you add a new character, there are only 2 cases, right? One is if it's a vowel. If it's a vowel, then nothing changes, and you just add the number of possible count that you already had. If it's a consonant, that means that now you have to do a next calculation, because that means you have to pop things off, right? I think that's basically the idea. I think they're all people are very smart about some of these things, but I am not. So we'll work through it together. But that's really the idea about this, is that you're able to kind of come up with what the invariants are, right? And here we kind of feel that we yeah. So there are only 2 scenarios, right? So here we set left is 0, 0, and maybe we want to keep track of 2 things. One is yeah, maybe the count of the values, vowels, not values, vowels, and then the number of consonants, right? So k count is equal to 0, and this is stuff within the window, which is left and right inclusively, right? So then now when we see if word of right is in vs, then it's a vowel. Then v of word of right, index to the we want increment, right? Yeah, and maybe we can do like a recount as well, is equal to 0, and then do the thing that we played around with, which is that if this is equal to 1, that means that now we have a new recount, right? Because it was previously 0. You can, maybe it's a little bit cleaner to write if this is equal to 0, then we increment, because then we know that we're incrementing, right? Else we know that's a consonant. Oh, and then the key here is that, well, now we want to say, okay, given this window, what is the contribution to total, right? And that's something that we have to figure out exactly, because right now we don't even know what the window is. So we have to kind of, for me anyway, it's sometimes you have to jump around to kind of clarify some of these things, but you know that what you want to do, is just that you don't know how you want to support the idea yet, right? This Wow contributes to the totals. So we have to kind of keep this a to-do kind of thing, right? Okay. Otherwise, it's a constant. What does it mean, right? So if k count, or well, let's just say k count increment by 1, right? So if k count is greater than k, that means that now we have to reduce our window, right? So now we want to at least pop until we ran out the window, right? Okay. So yeah, so that part maybe is fine, right? So while left, or while k count is, yeah, maybe this is a while loop now. Then while there, right? So left increment, but if word of right is in vs, or left, sorry. If the word that we're removing is in vs, then we want to decrement, right? And then now, if this is 0, then we also want to decrement. Sorry, whoops. Right? So otherwise, then now, otherwise we can decrement k count, and we're actually pretty much done, just because yeah, k count is going to be equal to 0, and we are Gucci, right? Yeah. And then the invariant now is that k count is equal to k. So then we just have to check whether we have enough wows, right? So if we count is equal to k, wait, no, is equal to 5. Whoops. So that means that we have all the values. Then now what can we do, right? Then now we have to try to count the number of contributions, right? And the contribution here is that, yeah, so then here we want to make sure that we want to count the degree of freedom that we have, is what I want to say. This is not easy at all, actually. But yeah, so for example, if you have like a lot of, I don't know, A's, A, E, I, O, U, and let's say you have one consonant and k is equal to 1, right? Then here, if let's say we have an x, we removed it, and then now this is the new thing, right? So then now you're able to kind of just find out, well, A, I, O, U is this. That means that everything to the left here is the degree of freedom. So that's basically what we want to keep track of, right? Yeah, and because we had previously seen a counter, that means that now we can actually reset the degree of freedom, right? So maybe our degree of freedom initially is 0, and then here, because we saw a consonant and then we removed that consonant, that means that everything to the right is going to be newish, right? So then now we have to kind of reset the degree, maybe. I don't know that this is right, honestly, just to be clear. It may be a little bit wonky. But I think that that's my current thing right now, is that we have degree is equal to 0, just that so we can count, right? So yeah. So then now, yeah. So while we count is equal to 5, I'm trying to think right now for all the cases. The thing is that I'm trying to be careful as well, because right now I think the invariant that I said is not correct, right? When I think about loop invariants, I think about not just loop invariants, but also the invariants of every possible state of code. And here, I think what I was thinking of that, okay, is that after this while loop, what does it mean, right? Well, after this while loop, k count is equal to k, right? But that's not true. K count is less than or equal to k. So I made an incorrect assumption there, and I wanted to make sure that, okay, I mean, you even see me doing this, right? K count is equal to k, which is not true, right? So we have to be a little bit careful. So maybe I want to just add it. I mean, it's not a hard thing to do. It's just that we have to be mindful, right? So here, okay, let's say right, then degree is 0 to 0. Okay, so then now this is how we ensure that our invariants are invariant, because, well, otherwise I guess nothing really happens because you just increment k count, which is also fine. Yeah. Anyway, now that we know, now that I made sure that the invariant is actually true, then now if there are 5 things, then we want to count the number of things until you know, this is not good, right? So okay, so then while we count is equal to 5, then if word of left is in vs, well, let's actually change it, right? So word of left is not in vs, then we break, because that means that we see another consonant. We don't want to take care of this consonant now, we want to do it in the future, so we just let it be, right? So then, yeah. And actually, degree of freedom is at least 1. It's not 0, because 1 is saying that if nothing changed, you have that one substring you can change, right? Meaning that, for example, if your string is already here, then you have at least 1 degree of freedom, which is to say you can only choose this string, and this is the only valid string. 2 degree of freedom is you have 2 ways, because then you could choose between either ending here or ending here, right? And so forth. Okay. Okay, so otherwise we want to say, yeah. We want to say kind of basically the same thing we have here, right? But it's a little bit nuanced, because I don't want to actually, I don't think I actually want to remove it. Or maybe I can, because I think if you remove it, then the degree of freedom will go to 0, will start at 0. So then when you remove it, it starts at 1. It's a little bit tricky. I don't know that I'm explaining it very well, but yeah, but you can do it the same way, right? Actually, I'm going to just copy and paste, right? Except for that, every time we do it, we increase 1, right? Because that's why we want to start at 0. It's at 1, because that means that 1 characters allow us to remove. And then now, when you have, when you remove all of these, that means that now you're 1 vowel or consonants away from, yeah, but now now that I changed the degree to 0, we actually have to change this a little bit as well, because I think now here we have to say degree of freedom is equal to 1, and then we let the future remove it, maybe. Right, because the case here, yeah, I don't know. I think like what I'm saying I believe in, but I feel like there are a lot of places to have off by 1 to silliness. So am I confident about this? Not at all, to be frank, right? But this is basically, we have like, I don't know, K, E, I, O, U, and then we added a new X, and then now we add another X. Now we want to, remove the window. Oh, no, this already did that, right? So actually, maybe the K is 2, so then maybe the 2 X's, right, to begin with. So it was like this, and then now we added this X, we removed this bad X, and then now we want to say, okay, well, we are going to remove this next, but well, we don't want to remove it, because then it allows the invariant, because what we want to do, or I want to do anyway, you could choose different invariants and maybe that'll work, but what we want now is that we want k count is equal to k as part of the, even after this while loop, and then, yeah, and I think that's the only thing, right? Yeah, and degree is equal to whatever, right? So then now the degree of freedom, we just add it to total, and we are good. Else, if k count is less than k, I guess we just don't do anything really, right? Because we just keep on expanding anyway. So I think we're good here. And then now here, going back to this to do, we can say, okay, how does this contribute to the topic, right? So now this is not as, maybe it is a symbol. Because basically the way that I want to think about it is just through some examples, right? So then maybe we have A-E-I-O-U, X where K is equal to 1, right? Do I have that from below? All right. Maybe not. And then now, if we get an A, what does that mean? Well, we still have the same degree of freedom of, let's say we have degree of freedom for, oh no. Actually, I am wrong about this, right? Because our invariant in this case is actually either the next character is a consonant, or if it's a vowel, then it's missing the first one. That's the, so that it has, right? So then now if you add a new thing, now the invariant is not true anymore because it's not missing one vowel. So we have to add to the degree of freedom. So then we have to do some math about degree of freedom again. And that is just, of course, the same code that we have here, right? So if we only care about the degree of freedom, it's here. So maybe it's something like this. But, and this is very hard to keep track of, honestly. I don't think that this is a great video. But yeah, so if this only happens if K counts equal to K, otherwise we just don't care, right? Because there's no invariant to withhold. The degree, I think it's we don't do that anymore. And then while this is 0 to 5, yeah, we want to increment the degree of freedom if we can. And honestly, it can only increment once just by the pigeonhole principle, right? Because this assumes that if this is ever true, while this is true, that means that we only added one character here to do this, right? So, like, this is the only way to get this to 5, and so this only adds 1. And I don't know that it can be a consonant, so. No, I guess it could be a constant. It's just that you don't increase the degree of freedom. And then now we just increment degree. I think this is such a ridiculous one. I don't know. Maybe past Larry did it smarter. I don't know. Okay, at least I guess at least we got those problems right, but this is very wrong, clearly. This is a tricky one for sure. So right, words up right, and then total, just to kind of give us an audit. Okay, so we have one at AU, so we have the 5 characters. At the Q, we have 1. Okay, the second Q, okay, then we have to get rid of everything. That's fair. And then 6, 7, 8, 9, 10. At the O, there should be 1. Nope, at the U. At the U, there should be 1. I guess my invariant here is not right then. No, this is right. It should added the degree to 1. Because then now, yeah. K count, right? Alright, let's print some more stuff out. The art of debugging. Okay. So, did I mess this up? After I... So QI, did I mess up an increment? Maybe I messed up a decrement or increment. Let's see. So we want V, right? I see. I mean, that definitely should not happen. Not sure what happened there. Let's see. What happened here is that we don't increment by left when we consume. Okay. And do we do the same here as well? Yeah, we also don't decrement. Okay. Well, I mean, you know, you can't keep on, you have to consume. Right, all right, there you go. So, I mean, actually a very silly mistake. I don't know why I keep on making this. Well, I think it's just because you just generally do not write the while the while loop that much in Python, or at least I don't, and I always forget about it. But we'll see if this works. Ooh, okay. I mean, like I said, I wasn't super confident about this, so it's not a shocking thing. Even I guess I'm shocked. I was just very hopeful. Okay, let's see. Right, so we output 3 when we expected 2. So k is 2. Let's see. So we need this, and then we have a u, and then the u, the degree of freedom would be 1. Oh, and then when we see the O again, we increase the degree of freedom again, even though that didn't change anything. That is a tricky case considering all the things that we're talking about, because I don't even know how to think about it. The state diagram for this one is hard. Okay, so if it is a consonant, that means that the only way it's only if it went from 4 to 5 in this here that you want to do this, or do the degree that incrementing, right? Because the incrementing is only assuming that we now just completed a thing, right? It is for the case of, say, you have C, A, E, I, O, and then when you get to U, well, now you have a 1 degree of freedom that you went from 0 before. But if you already have a degree of freedom, meaning that, yeah, okay. So I think this is, I don't know if this is a hack or not, honestly, because this only happens if it went from 0 to 1, and it fits this one because we kind of want to fix this one, but I'm not sure that this is sufficient. So I guess we'll see. Oh no, okay, so we're definitely not sufficient. Greedy problems are my issue. I got it right last time, so maybe I'm just thinking about it a bit differently today. Okay, so why is this not right? So you have k. I mean, I think the way that I worded the state diagram is just terrible. But okay, so k is 2. So we have, so it has at least this, right? So here, what's the degree of freedom? So we have a q. So then now we go do, right? Oh, okay, yeah, this is not right still, because now, I mean, okay, I mean, what I was saying was right, but my notation isn't right, which is that I want this to be only if it went from 4 to 5. So I guess maybe we just should be more precise. I thought that would be a good proxy for it, but I was wrong as shown in this case. So maybe I want something like, yeah, if we count, or maybe I should just put it here, really, right? Which is that if we count, or rather, no, I can't just put, I mean, I could, but, or maybe I could just remove this. So here, the degree is not +1. It is that if recount is equal to 5, then degree +1 here. Okay. Right? Okay, but now it's wrong for this one. Why? A-I-O-U? Oh, because for k is equal to 0, it's a little bit awkward. Is it? It just went to 5. It has to be that it just went to 5 and previously the degree is 0. Right? No. No. The degree, because that's the one that like case 4 about, right? Or something like this. I forget which one. Because then now, no, not this one. It's this one actually. Because here, then now it would write because then you have here, the degree of freedom is actually extended to here. So then with the I though, you don't reset the degree of freedom. Something like that. Nope, I forgot that. Now I'm not doing anything right. Okay, let's reset for a second, right? Okay, so this is what I had. And this part, I'm not even sure that's that about. Just kind of, okay, so let's take that out. Okay. So the idea of why this is wrong is because basically, I'm just trying to refigure from principle. We have this, we have Q, and then, because we have A, E, I, O, U, and then when we see a Q, we... Oh, no. It's this Q first. A, E, I, O, U. So then now... I'm trying to think whether I can pivot to another answer, because the way that I'm doing is really not great, as you can see. Yeah. Here, we don't count it, right? That was the issue that we were running. And it's because we went to 5. We have a consonant, but okay. I mean, I think the way that I want to think about it now then is just have a new invariant. I think the invariant that we were working with is not great. I think the invariant that we want to work with is, instead of this like weird recount is equal to 4 type thing, we want to actually keep recount is equal to 5. I think that is maybe the better invariant and degree of freedom thing. And now that we have that new invariant, we can make sure that every state of the way that is true. And I think that will allow us to kind of get a better counting, right? So what I was a little bit doing was I was a little bit sloppy with respect to just like, oh, this is a good enough invariant for us, but clearly it is not. And you could see that I struggle for 37 minutes. Is this video that long? Wow, what have I been doing? Am I just chilling? What is going on? Anyway, but yeah, so then now we don't even hold this anymore. So then now if we count, so we subtract, right? So then maybe we can do something like if this is equal to 1, then we break. Because if this is equal to 1, that means that if we subtract 1 from it, then we're done, right? So here we want to say that actually we always have a degree of freedom because, well, we have K. Maybe here, right? So we remove any unnecessary characters, which is only values, of course, until we can't. And then when we can't, then yeah, we can remove this here. And then I think this is fine. I want to say so. I don't know. And then here now, we want to keep track. It's a little bit messier, but I think the count is a little bit better. So then here, the same idea, which is that, okay, now if it's count, right? So if this is equal to 5 and we want it to be equal to 5, then we want to make sure that we have the degree. Yeah, we want to just count the degree, right? Yeah. If it's a consonant, then we can't remove any more. Otherwise, I'm trying to think. How do you get the first degree? Or where do you put the first degree, right? Like, if it was already 5, then it wouldn't change anything, right? So that means that here, maybe, right? So if we count is now equal to 5, then we want to say degree is equal to 1. Oh, no. Well, we want to say degree is equal to 0, because that means that it's a new degree anyway. So then we would just reset it. And then here now, that means that well, K count cannot change, right? So that means that if we count is equal to 5, then it's either whether it's new or not. And whatever it is, we have at least 1 degree. And then we just kind of do this thing, which we will kind of steal from before, which is this thing, right? Okay, it's a little bit yucky though still, but okay, let's see why we're getting it wrong. So we're over expecting. Why? Where's my print statement? I mean, I probably could have worked it out, but ooh, oops. But I just want to see this. Okay, so here, 1 on the U, fair enough, and then on the O, it thinks it has 2 degrees of freedom. Why does it do that? It cannot remove anything. Oh, right. So it's not a new 5. So that means that maybe I meant this as an nk count is equal to k. And then now we can say we don't increase here. Do we ever increase? Yeah, I guess so. We do. There is a degree of freedom, but only if it's a vowel that we can remove without penalty, right? Oh man, this is like a whack-a-mole, and I'm just getting everything wrong. A-I-O-U, right? K is equal to 1 is actually maybe a weird case. I don't know if I should special case it. But okay, so it's equal to 0, so we, yeah. And then now, oh no, this should be 1. Yeah, because this means that we now have it and we don't count it before this anymore. So, okay. Am I confident about this? Honestly, not very, but I think the states make a little bit more sense. Let's go submit. Honestly, not very proud of this one. 42 minutes. Definitely did worse than last time. How did I do last time? I mean, can't say I cheated because who would cheat like this? Okay. I don't know. Oh, I do remember this idea. I'm not very good at this idea. Did I solve this during the contest or afterwards? I feel like... Okay, this is my... Maybe this is my pre-cleanup contest code. I don't even know. Honestly, I don't know that I solved this one during the contest. It seems like I submitted it after the contest. So maybe I just didn't solve this one during the contest. Because I remember, now that I see the solution, I remember this one being a little bit hard. And I don't know that I'm a fan of... I mean, this is a ridiculous solution though. I definitely recommend you watching that video for the explanation. But it does make things a lot easier, I think. Yeah. But this is the way that I have it today, and with the invariants and so forth, a pretty tricky problem. Maybe I'm just not good anymore, but yeah. But I definitely did it a different way though. It's still with more sliding window. The idea is just to keep track of the invariants, but the invariants are kind of tricky, as you can see. With the degrees and the states and stuff like that, it is all sort of awkward. Yeah. Yeah, I'm trying to think whether I can simplify this at all. I mean, I probably can, but I don't know if I can, right? I mean, someone could. I don't know if I can. I am going to call it a night. My apologies if this is but hopefully I kind of show you a little bit about debugging and changing the ideas about invariants and stuff like this. This is a very long video. Maybe it's not very explanatory for this problem, but maybe I gave you some ideas on how to debug it. But yeah. and just try to keep track of the invariants and switching up the invariants when you need to. And when at the end we got the k and v count is equal to 5 invariant. But very tricky to get all the states correct with the degree is equal to 1 and setting the degrees in the right place. I wonder if there's a easier way to think about it, but yeah, I don't know. Yeah, I don't know. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye. Actually, I lied about that one. I just want to do the complexity. I think I was just so kind of confused out that I forgot to do complexity. So the complexity, just on a very brief note, this is an O of n loop. There are some while loops, but all those while loops increments left, and left can only go up to right? So this is O of n because left can increment only n times, even though it may not look that way. But yeah, so this is linear time, constant space, right? Everything is constant. So yeah, that's all I have for this one, actually. Let me know what you think. Thanks for watching, and yeah, you can stay good, stay healthy to your mental health. Have a great week, everybody. Happy Mario Day. I'll see y'all later and take care. Bye bye.